Hello and welcome once again to my channel. In this lesson, we're looking at health issues. Health is the state of physical and mental well-being. Diseases, both infectious, communicable, and non-communicable, are major causes of ill health. However, factors such as diet, stress, and lifestyle situations may also have a profound impact on both physical and mental health. Now, I've done a little summary here of the knowledge that you should have in order to move forward in this lesson. So when we talk about health, just like the starter activity suggests, it's a state of physical and mental well-being. And then this can be affected by diseases such as, for example, cancer, which is non-communicable, and diseases which are caused by microorganisms or pathogens such as, for example, COVID. Now, diseases of the immune system, which would be non-communicable, can interact, and you're more likely to get an infection when they interact. So, communicable diseases, or rather non-communicable, you have heart disease, cancer, diabetes, among many others. Then, communicable disease, you have examples like influenza, the flu, measles, COVID, HIV, gonorrhea, athlete's foot. When you say communicable, it means it is caused by a pathogen. Pathogens such as viruses, bacteria, fungi, protists, etc. And then pathogen basically means that it is a disease-causing organism. It causes a disease when it enters your body or gets onto your skin, etc. Communicable infections or infectious diseases are caused by pathogens such as bacteria and viruses and can spread from person to person. Can you name at least one communicable disease? So if you refer back to the previous slide, one communicable disease would be, for example, COVID, which we all experienced 5 years ago. HIV, athlete's foot, etc. What is a non-communicable disease? A non-communicable disease is one which cannot be spread from person to person. For example, diabetes, heart disease, arthritis, etc. Describe what factors can affect health. So, you have many different factors that can affect health. Diet, stress, life situations. So, in terms of diet, if you cannot get enough to eat or the right nutrients, you may suffer from diseases like anemia or rickets. Rickets is where the legs bow. Too much food may lead to obesity, cancers, and type 2 diabetes. These are called deficiency diseases. Stress. A small amount of stress helps us to function. However, high levels of stress can be linked to cancer, heart disease, and mental health issues. These are non-communicable. It only affects the person. Life situations, where you live, gender, your financial status, ethnic group, level of health care, number of children, rubbish and sewage disposal in your area. People don't have much control over life situations. When you're young, however, these cause ill health. So you don't have much, so it depends on where you live. You know, in terms of the NHS, sometimes they say it's a postcode lottery. how quickly you may get to go in, for example, for cancer screening, your financial status, depending on your qualification, the jobs that are available, how much you're paid, your ethnic group, your gender. Men are generally paid more than women. Where you live, you can't afford to buy a house in a more expensive area, so you're limited to where you live. And then, of course, it's how the council manages different areas. That's kind of out of your control. Different diseases, like I've said earlier, interact. We're going to look at some. Example, viruses can cause cancer. The HPV, human papilloma virus, which young people are vaccinated for, I think in year 9. Poor nutrition or HIV/AIDS means your body's immune system cannot fight infection. So when you have HIV, it compromises your immune system. It opens you up to a lot of other infections. Pathogens can trigger allergies. Severe ill health can lead to mental health, because if you're not well, it's going to make you very stressed. Malnutrition can lead to lots of issues, example, scurvy, cancer, heart disease, etc. Allergic reactions due to bacteria and viruses. So hives, you can see the rashes on the arm. Viruses and bacteria can trigger a condition called hives. As the immune system works to destroy the virus and bacteria, an allergic reaction, or rather response, such as hives, can be caused. Hives cause red, itchy, raised areas of the skin and can be short-term or long-term. Asthma. Asthma can be linked to exposure to disease-causing organisms called pathogens, such as bacteria and viruses. As the body fights off the bacteria and viruses, it can result in an allergic reaction and cause asthma. Data support that diet can reverse heart disease. So you can pause the video and have a read through this section. Different types of diseases may interact. The graph below shows the percentage of risk of infections caused when the activity of the immune system changes. So on the y-axis, you have risk of infectious disease percentage, and on the x, activity of human system, or rather activity of immune system. So the question says, what is the correlation or pattern between activity of immune system and risk of infectious disease? How can you use the graph's data to prove your conclusion? What conditions may cause a low activity of the immune system? And what does this increase? And what conditions may cause a low activity of the immune system? And why does this increase the risk of infections? So it's here you would pause the video and have a look and see if you can answer these questions on your own. So for the first one, you can see that as the activity of the immune system increases, the risk of infection decreases, or the risk of infectious diseases decreases. Number 2 says, how can you use the graph's data to prove your conclusion? Well, at an activity of immune system of 20, the risk of infectious disease is 60%. However, at an activity of 60, the risk of infectious disease is lower at 10%. Next one. So do those. And then what conditions may cause a low activity of your immune system? So like previously discussed in previous slides, it would be diseases that, for example, infectious diseases, they can compromise your immune system. Or non-infectious diseases would be, for example, cancer. Infectious ones would be like AIDS. So AIDS, HIV, that compromises your immune system. It renders your white blood cells ineffective at protecting you. Cancers such as leukemia, already being ill as the immune system is already working overtime. What conditions, so we've done that. Why does this increase the risk of infection? Well, if your immune system is compromised, like I've said earlier, your white blood cells are working overtime, then it then opens you up to catching or contracting other infections. So if your body is compromised or the white blood cells are working at their maximum rate against another infection, it means that your body is likely to be more susceptible. So it opens you up, it compromises you to other conditions, that is flu or food poisoning and other conditions. Next one, risk of cervical cancer caused by HPV viruses. So you have risk of cancer, number of HPV. So you can see your risk increases. So that when the number of HPV virus inside cells in the millions increases, it also increases your risk of cancer. So what is the correlation? Number 2, how can you use the graph data to prove your conclusion? 3, at which point does the number of HPV virus change the risk of cancer? And 4, describe the change. So you would look at the data. So you read the y-axis, which is risk of cervical cancer. Read the x-axis, number of HPV viruses inside the cell. Follow the line of the line of best fit. Look at the number of HPV viruses in the millions, and you notice that it increases. So as the number of HPV virus increases, look at what is happening to the risk of HPV or rather cervical cancer. So as the number of HPV viruses increases, the risk of cervical cancer also increases. Number 2, how can you use the graph's data to prove your conclusion? Well, you can see that at 2 trillion HPV virus, now you can pick at any point here. So 2 trillion HPV viruses inside the cell, the risk of cancer is 3%. Yep, so at here, it's about 3%, whereas at 4 over here, you notice it is now 7%. And at 8 trillion HPV viruses inside cell, so at 8, you notice it shoots up to 31%, which is, that's a significant increase, a significant risk of cancer. So there you have it. Next one says, at which point does the number of HPV viruses change the risk of cancer? So back to the graph. At which point does the number of HPV viruses change the risk of cancer? And I'd say around 5 million HPV viruses, the risk of cancer significantly increase. So it's, yep. And then it keeps going. And then describe this change. From 0 to 5 trillion HPV viruses inside cells, the risk of cancer increases slowly with a range of about 9%. At 5, however, the increase significantly rises to 15% and continues to rise significantly. All right. Deeper thinking, childhood asthma due to pathogen exposure. So where people live, risk of childhood asthma due to pathogen exposure. So within city center, 10. In rural countryside, 15. In housing estate, 9. In village, 12. On a farm, 17. So it says draw a graph and show the risk of childhood asthma caused by pathogens in different areas, and compare which areas cause childhood asthma due to pathogen exposure, and explain your result. So this one you can do on your own because you'll have to draw the graph, and then you interpret the data that you get back. But all in all, in this video, it looks at the correlations or the interactions between diseases, interaction between communicable and non-communicable diseases, how they impact on the immune system, how your general health is affected when you are exposed to communicable diseases, and how they impact on your immune system. Please watch this video a few more times. Listen to all the key points, as well as you can pause and read for yourselves. And then hopefully by the end, I say watch it about 3 more times. And then hopefully by then you will have gotten the gist of what the lesson was about, which is health issues. Thanks again for watching, and please like and subscribe and come back and watch some more of my videos. I will continue to post and hopefully cover as much of the biology GCSE content as possible. Thanks again, and